So we're going to be looking today at an application of proportions called scale drawings. If you've ever taken a picture with your phone or looked at a map, you're taking things that are large and you're shrinking them down into a smaller size. Could be a drawing. Sometimes we even take things that are smaller and make them bigger. So if you've ever looked at through a microscope in science class, maybe you've drawn a picture of what you're seeing where you're enlarging it. Okay. So scale tries to keep things proportional. Okay, so we'll look at what that means and how to solve some problems with that. So a scale drawing is simply a drawing that's similar to an actual object. So we've talked about the idea of being similar, right? The angles stay the same, the ratios of corresponding sides stay the same, that type of thing. It's just made bigger or smaller. Okay. Scale drawings have a scale that tells us how those ratios, or what that ratio is, and how the actual thing compares to the drawing or the model. And throughout this, when I say drawing, I could be talking about a drawing like on a piece of paper. Drawing could refer to a picture, even like a 3D model. We'll just refer to all of that stuff to a drawing. It's not the actual thing, it's the other thing. So when we look at the scale's in a specific order. You got to make sure the top number in the scale is referring to that drawing. The bottom number is referring to the actual size. Okay. So example here, I have a rectangle. It says in the scale drawing 1 inch equals 3 feet of floor. Right. So maybe you're putting some carpet down in your room or something like that. Have a scale drawing of it, trying to figure out the actual size. So we want to know what is the actual length of the room. All right. So we can see the scale written there as 1 inch equals 3 feet. Okay, and you can see it written like that. You can see it as a fraction. Sometimes you might see it with that colon in again because it's a ratio, so it can look different ways. Okay, but that's just saying 1 inch on the drawing is 3 feet in on the actual room, right? It wouldn't make sense to say 3 feet of the drawing is 1 inch of the actual. So the first number represents the drawing size. The second number represents the actual. Okay, so we're trying to figure out the actual length of the room. We know on the drawing the length is 6 inches. Okay, so all we're really going to do is use a proportion, right? Now, the nice thing about these proportions with scale drawings is you already have half of the proportion. Your scale is going to be half of that, okay? So you can see one part of the proportion there is 1 inch to 3 feet, okay? 1 inch to 3 feet. And then we simply want to plug in the other number that we know, okay? So we just have to make sure we match up the part correctly. Since 6 inches is the drawing size, we want to make sure we put it on top of that proportion, okay? Sometimes you can just mental math figure it out and go, well, it's going to get bigger, so I'm going to multiply by 3. So depending on the situation, sometimes it's hard to decide, do I multiply or do I divide? So the proportion kind of takes the guesswork out of that, right? So we can see there we're going to do 6 times 3 to get 18, right? 18 divided by 1, just 18. So the length then, when we multiply it out, is going to be 18 feet, right? And again, labels are important, right? You know, if you have a room that's 18 feet versus 18 yards versus 18 inches, much different. So make sure we're including labels on this stuff, okay? But again, we just have half of our proportion is that scale, and then we plug in the number we know, solve for the one that we don't, okay? Again, one of the most common uses of scale drawings is in maps. So I have just a pretend map there of Fogsville and Springton. It says a map shows the road between the cities of Springton and Fogsville. The legend of the map says that 2 inches represent 5 miles. If the distance between Springton and Fogsville is 17.5 miles, what is the distance on the map? So it's kind of different. The first one, we were given the drawing size, trying to figure out the actual. Here we're given the actual, we're trying to figure out the drawing size, okay? So if you're creating a map or you had to figure out what that distance was between those two on the map, right, we could use that. So we've got our legend there, which is just a name for our scale on our map. 2 inches is 5 miles. And again, we're just going to set up a proportion of the scale being half of the proportion. Okay, so we'd 2 inches to 5 miles. So you can see the scale there. And then again, 17.5 miles is the actual distance. So actual goes on bottom, drawing over actual. So we're trying to figure out the drawing size, actual goes on bottom. And a lot of times you can use the labels to help you kind of match up where parts go to. So again, we just want to cross multiply there, 17.5 times 2 divided by 5, and the map distance comes out to be 7 inches. Okay. Now sometimes with scale drawings we want to rewrite them without measuring units. The nice thing is, like in this map, if if I was working in centimeters or kilometers or something like that, I have to do a whole bunch of converting to figure that out. So if we have a scale without a measuring unit on it, you can really use any measuring unit you want, right? If the scale is 2 to 5, right, that could be 2 centimeters to 5 kilometers, whatever. Okay, so we're going to look at how do we rewrite a scale that has measuring units into scales that don't. Essentially, we're going to follow these steps. So we want to convert one measuring unit to the other. There's advantages to which one you do. If you convert the larger measuring unit, so let's say I have inches and feet, feet's the larger measuring unit. So I could convert the larger one into the smaller one. Okay, you avoid decimals a lot with that, but the numbers tend to get bigger. If you convert the smaller measuring unit, so let's say I converted inches into feet, the numbers tend to stay smaller, but sometimes you end up with a decimal that you have to do something with. So, there's advantages to both ways. It really kind of just depends on the problem and how easily they convert back and forth. So we're going to convert one of the measuring units to the other, multiply to get rid of any decimals if necessary, and then we simplify it and simply drop the label. So let's look at an example here. We write the following scale without measuring units. So we've got 6 inches to 2 feet. So we'll look at both methods here. All right. So this first one, I'm going to convert feet into inches. Okay, so I'm going to take the larger measuring unit, convert it into the smaller one. So 2 feet, there's 12 inches per foot, so that's 24 inches. Okay, so you'll notice I've taken 6 inches over 2 feet and I've rewritten it as 6 inches over 24 inches. So my 2 feet is now 24 inches. Okay, I can simplify 6 over 24 is 1 over 4. And then since they're the same measuring unit, we can drop them. Okay, just like, if I have something in the numerator and the denominator, they cancel each other out. So simply 1 to 4. And again, the advantage there, I don't have to worry about using inches and feet. If my measurement's in centimeters, I don't have to convert to inches first or whatever. Okay, so I took the 2 feet, converted it to inches, simplified, dropped the labels. Okay, now the other method, this one I'm taking the inches and converting to feet. So 6 inches, and I'm going to divide by 12 since there's 12 inches per foot. So 6 inches is a half a foot. 0.5 feet there. Okay, now the numbers are smaller on this one, but I have a decimal. So you'll notice what I did was multiply both the top and the bottom. You got to do it to both. You can't just do it to one. If I change the top or the numerator, I got to change the denominator to keep it equal. So I multiply by 10, so that decimal would move over. So 0.5 becomes 5, 2 becomes 20, and then again we simplify. 5 over 20 simplifies to 1 over 4. Then we can drop the foot and the feet there to just get 1 over 4. So this one I would probably argue method 1 is going to be quicker. Again, if you're looking at some larger conversions, maybe you're doing centimeters into kilometers, something like that. I don't know, but sometimes it's more beneficial to keep the number smaller. Again, the advantage is you don't have to simplify as much, but either way works, right? To me, this is the convert the bigger unit into the smaller one. You don't have to deal with the decimals. So if you're unsure, maybe go that route, but you can do it either way. Just got to make sure if you end up with a decimal point in there, you get rid of that decimal point before you simplify. Okay, so again, that's rewriting scales without a measuring unit. Okay, which again is beneficial. Sometimes our scales have measuring units, but as you're working through your problems here, again, keep this in mind, right? That ratio is always the drawing to the actual, right? It's important you keep it that way. And then it's just a matter of picking up which other piece of information you know and getting it into that proportion in the right spot again. A lot of times those labels will help you out with that. Okay?